Welcome to Sonu Polity Physics class. Okay, students. Today we will discuss about the relation between beta and gamma function. The relation is beta mn is equal to gamma m plus gamma n by gamma m plus n. So see how to prove this. So prove. We know by the definition of gamma function we can write gamma n is equal to 0 to infinite e to the power minus x into x to the power n minus 1 dx. Okay, students, and also by the property of gamma function we can write that gamma n is equal to z to the power n 0 to infinite e to the power minus zx into x to the power n minus 1 dx. Okay, and here z to the power n is multiplied with this term, so we can write gamma n by z to the power n is equal to 0 to infinite e to the power minus zx into x to the power n minus 1 dx. So this let equation 1 and this equation 2 and this equation 3 let. Okay, so see, by the definition we can write this, and by the property of gamma function we can write this. Okay, so we have to prove this relation. So to prove this relation we have to multiplying equation 2 of both sides by e to the power minus z and z to the power m minus 1, and integrating both sides, integrating from 0 to infinite. So see, to prove this relation we have to multiply this equation 2 of both sides by e to the power minus z and z to the power m minus 1 and integrating from 0 to infinite. Okay, student, so multiply e to the power minus z and z to the power m minus 1 both sides of equation 2. So see, when we multiply, then gamma n into e to the power minus z into z to the power m minus 1 integrating from 0 to infinite dz. This is so again we multiply e to the power minus z and z to the power m minus 1 with this side. So we get e to the power minus z into z to the power m minus 1 dz integrating from 0 to infinite, and this term also multiplied with this, so we can write into z to the power n 0 to infinite e to the power minus zx into x to the power n minus 1 e to the power minus zx into x to the power n minus 1 dx. Okay, so multiplying equation 2 with both sides e to the power minus z into z to the power m minus 1, so we multiply e to the power minus z and z to the power m minus 1 and integrating from 0 to infinite. So both sides we multiplied, both sides of equation is multiplied with e to the power minus z into z to the power m minus 1. Okay, so when we arrange this, see, we know by the definition of gamma function, gamma n is equal to 0 to infinite e to the power minus x e to the power minus x into x to the power n minus 1 dx. So see, in this term, in the place of n here is m, okay, in the place of n here is m, and in the place of x here is z, okay students, and in the place of dz here is dx. So we can write in place of this integration, that is gamma m, because in the place of n here is m, so we can write the value of this integration as gamma m. So see, we can write this integration value as gamma m. So this implies gamma n into gamma m is equal to, so see, when we arrange this, there is double integration 0 to infinite. So see, e to the power minus z, e to the power minus zx, e to the power minus z, e to the power minus zx. So when we multiply this, so the powers are added. So see, e to the power minus z minus zx. So when we take common z, so we get z minus z. When we take common, that is 1 plus x. So e to the power minus z into e to the power minus zx. So we get e to the power minus z whole into 1 plus x, that is e to the power minus z whole into 1 plus x. Okay. Here is z to the power m minus 1. Here is z to the power n. So we can write z to the power m plus n minus 1. And here is x to the power n minus 1. That is x to the power n minus 1 dx and dz also. So we know how solve the double integration. So first we have to separate one variable. First we separate e to the power minus z1 plus x into z to the power m plus n minus 1. First we have to separate the z variables. So this implies gamma n, gamma m is equal to 0 to infinite. Here x to the power n minus 1. We have to separate the z variables. So 0 to infinite e to the power minus z 1 plus x into z n plus n minus 1 dz, okay, dz into dx. Okay students, so by the property of double integration, we have to separate one variable from two variable. So here is two variable, that is z and x. So we have to first separate the z related terms. So first we separate e to the power minus z1 plus x into z to the power m plus n minus 1. So see, we know, so you can take the screenshot of this. Okay, so see, we know that by the property of gamma function, we know that gamma n is equal to z to the power n into 0 to infinite e to the power minus zx into x to the power n minus 1 dx. So see, here in the place of x, here is z. Okay students, compare this property of gamma function with this equation. Compare this property of gamma function with this equation. See, in the place of x, here is z, and in the place of z, here is 1 plus x. See, again see, when we say about e to the power minus zx, okay, here in the place of x, here is z. So in this z also we can compare with this as x. Okay, so in the place of x, here is what, 1 plus x, and in the place of x, here is z, and in the place of z, here is 1 plus x, and in the place of n, here is m plus n. Again see, in the place of x, here is z. Okay students, in the place of n, here is n minus 1, so here is m plus n minus 1. In the place of n, here is m plus n. Okay, and in the place of z, here is 1 plus x. Okay, so by comparing this we can put the value of this. Okay, so see, in the equation 3 we write that gamma n by z to the power n is equal to, here is z, so we can take here in the place of x there is z, and then in the place of n here is m plus n, and in the place of z here is 1 plus x. So we can write gamma, this implies we can write gamma n into gamma m is equal to 0 to infinite x to the power n minus 1. In the place of this we can write that gamma n, so in the place of n here is m plus n, so in the place of gamma n we can write gamma m plus n by, in the place of z here is what, now 1 plus x, so in the place of z we can write 1 plus x to the power n. Okay students, so see again here is dx, so again see, here gamma m plus n is a constant, so we can take this outside. Okay, this implies gamma m is equal to m plus n, gamma m plus n 0 to infinite. Okay, so here is x to the power n minus 1 by 1 plus x to the power n dx. So in the, here is gamma m plus n is a constant multiplied with this term. When we take this to this side, then it will be divided with this term. So this implies gamma n into gamma m by gamma m plus n is equal to 0 to infinite x to the power n minus 1 plus x to the power n dx. So as we know that by the property of beta function, we know beta mn is equal to integration from 0 to infinite x to the power n minus 1 by 1 plus x to the power n dx. So in place of this term we can write beta mn, so this implies gamma n into gamma m by gamma m plus n is equal to, that is in the place of this term we can write beta mn. So proved. This is the relation between beta and gamma function. Okay students, so thank you students.